My name is Jill Clark and I'm one of the trainers at JBI. The short video that you're about to see is about test-driven development, TDD. It's one of the short demonstrations that we do during the Clean Code course, also known as Software Engineering Development Standards. In this particular video, I'll be taking you stage through a very simple example of how you can use test-driven development in order to build a set of tests alongside the code that you're building. At the end of this practical example, generally on the course, what we do is upload the example and get the students to then spend about 20 minutes adding in an example of their own, just so that they get a chance to try this out. So this is the demonstration part of test-driven development from Clean Code. So the first thing that we do is we'd go to the Jest webpage, which allows us to do a setup of getting Jest, which is a testing framework, ready to use with JavaScript, which is the language that I'm going to use for the demonstration. So here's the link for it, jestjs.io, and we're looking at the Getting Started page. You can see that we've got people to install the Jest product itself, and this is going to use a folder within my system, which I've already set up in advance. So this is where you get the information from initially. Within this setup, they already give you an example function, which adds up 2 numbers, and they also give you an example test, which tests the function, which adds up 2 numbers. Now, this is unit testing, okay? This is the sort of testing that we generally expect all developers to do when they were developing their code for a project. I'm going to close this down now because I've already done this on my machine. So here's what you'd get if you did that installation from the Jest setup pages. You'd get your node modules, which are all the node dependencies, which will allow Jest to run. You'd also get your function that you're going to be testing, and you'd get a file with the tests in. This packaging is just all part of the node service, which sets up any of the version dependency information and also sets up which particular product we're using for testing Jest, as I've said. So the next thing that we need in order for this to run is a command line. If you're using an Apple Mac, it'll be the terminal. Again, here's one that I've pre-prepared. What I'm going to do is I'm just going to change my path into the folder that was got all of my testing in. So there's the path that I'm using. And the first thing that I'm going to do is I'm just going to run what I've got in there now, which is the tests that come from the Jest setup page. Okay, so all we need to do is npm node package management, run test. And you can see here that it's run what's already in that folder. So what that's told me is that my existing function and my existing tests are working. You can see there, 1 test has been executed, 1 test has passed. So that's my starting point. Okay, run the tests with what you've got, even if what you've got is nothing, to make sure that at least the setup and the folder is working okay. So that's great. So now let's go back and let's have a look at what we've already got. So I'm going to open these up. I use Visual Studio Code, but of course any good editor will work. And here's my simple function written in JavaScript, which adds 2 numbers together and returns the result. Here's my simple test written in Jest. So this requires the function and it runs a simple test. The first part of the test is the title. The second part of the test is the actual test itself that you're going to do. This is human readable. If we call the function and pass across the values 1 and 2 into the parameters, we will expect the result to be 3. Okay, so that's how you read that existing test and the existing function. So let's move on from there. We're going to use test-driven development techniques to add in a new function that divides two numbers. With the test-driven development, we start off with the test. So the first thing that I'm going to do is build a test to test my divides two numbers function. So I'm going to copy this first. I'm going to open up a new file. I'm going to paste that in. And now I'm going to make the changes I need to set up my initial test. So first of all, I'm going to change the names here. There's always a spelling mistake if someone's watching you, isn't there? Standard practice. So this is the initial test that I'm going to do. I'm going to give it the title, divides 2 by 1, expects the result to be 2. And then I'm going to put in a very simple test, quite similar to the one that we had before, where I call the function with the two values, and I expect the result to be, in this case, 2. 2 divided by 1, 2. I'm going to save this file. Now this is the test file. So we add in the name of the function .test.js. That's the naming standard for our test files. Okay, so I've written my test. What I'm going to do now is I'm going to run that test. I know what you're thinking. You're thinking, but it's going to fail. You haven't written the function yet. That's exactly what we're intending with test-driven development. With test-driven development, we have 3 stages that we go through. Okay, red, green, blue. Okay, fail, pass, refactor. So those are the stages. So I'm going to run this, expecting it to fail. I'll tell you why I do that in a moment. Let's run it first and watch it fail. So I'm going to do the same thing. I'm going to run the tests. Okay, so we can see that the original test and function, which adds 2 numbers, has still passed. Great, we haven't broken anything. That's good. So we're testing here to make sure we haven't broken anything we've already done. We're also testing our test. And this is why we run it, knowing that it should fail. Because if we run it and our test passes, then we know that our test would give us a false positive. So when you run it knowing it will fail, you're making sure that it does fail. In other words, you're testing the test to make sure it's been written correctly, so that if there's nothing to test, it does fail. Okay, so we can see that. Let's have a look now and see what the error was that it gave us. You can see here that it can't find the module divide two numbers. No surprises. Okay, let's fix that. I'm going to copy this, and you're thinking, oh, she's cheating again. She's doing copy and paste. No, really? Bear with me. I'm going to open up a new file. Oops. Bear with me. Trust me. All I've got to fix here is the fact that it can't find the function. So actually, I'm not going to leave this like this. What I'm going to do is break it down to the smallest possible thing that fixes the error that it gave me. So have the name that it needs. Now, okay, so you can see here that all I'm doing is I'm fixing the error that the test run gave me. And the error it gave me was, I can't find the function. So here's the function. It doesn't do anything, but here's the function. So that should fix the error. So let's save it. Okay, let's go back to our command line and let's run our tests again. Okay, so here we go. First of all, add two numbers is still working. So that's great. We know that we haven't broken anything that already existed. The test for divide two numbers, however, has failed again. Okay. This time, however, we've got a different error. So again, we're testing the test to make sure it hasn't given us a false positive, but also to make sure that it can find the function that it's looking for. However, it's still giving me an error. What that error says is object inequality. In other words, I'm expecting the result to be 2, but actually the result is undefined. I don't get a result out of it. So now, test-driven development dictates that we go back and fix just that error. So let's go back and do that. Okay, that'll do it. That'll fix the error. Again, you might be thinking, but that's not the functionality that we want. Bear with me. Let me explain how we're doing this. Step by step, stage by stage. One of the things that we're trying to do with test-driven development is provide the minimum amount of code that we need in order to make the test run each time. We're going to fine-tune it as we go along. What you find when you're working with test-driven development is that you start from specific and go to generic. In other words, I return a fixed value. Okay, this is testing my tests again to make sure that they work if they get the correct value back. So this time we're making sure that the test does give us a positive when we're expecting a positive. However, from the functionality point of view, that's not nearly generic enough, is it? I want to be able to pass two numbers across and have it return a result based on those two numbers. So I give it a specific value just to test that the test is okay. But then I change it to a generic value to make sure that the function is okay. So let's run this again. I'm going to save it. And then I'm going to run my tests again. Okay, result. Both of them passed. So we haven't broken anything existing, and we know that our test gives us a positive when it should give us a positive. However, the function's not generic enough yet. So let's go back and fix that. Okay, so now I've made the function more generic. I've made it so that it can accept different values and that it can do the calculation based on those values. So let's run it again. Perfect. So now we've built tests that will exercise the function divide two numbers, and we've built the divide two numbers function that will be tested by those tests. We built them stage by stage, fixing only the problems that we're given each time. We started off knowing it would fail, that's the red. We then fixed it so that it would run, that's the green. And then we refactored. So we changed it and kept running that cycle until the test was complete and the code was complete. Okay, red, green, blue, fail, pass, refactor. That's test-driven development. What we'd normally do in the course now is we'd normally pass across a copy of those files to the attendees on the course, and we give them 20 minutes to build another test and little bit of code. One of the standards that we talk about in our Clean Code course is robust coding standards. So we'd be talking about building your code so that it manages errors elegantly and efficiently. And what I get them to do now is to add in a test to see what happens if you divide something by 0. And then refactor the code so that we build in the error handling that manages that failure elegantly. Okay, thank you for watching the video. Goodbye.